Graph Theory Class 6 Video 2. In this video we're going to continue classifying simple graphs with few vertices. In the previous video we classified all simple graphs with 3 vertices, and we realized that there are only 4 such graphs. This time let's look at classifying simple graphs with 4 vertices. So example, classify all simple graphs with 4 vertices up to isomorphism. Okay, and something you'll realize when you start attempting these sort of questions is, as the number of vertices increases, the difficulty of this question increases exponentially. Okay, so in order to do this, we need a methodical way of trying to classify these graphs. And I think the simplest way of doing this is to try and classify based on how many edges they have. So if I think about number of edges, okay, well, 0 edges, it's quite simple, right? There's just going to be this graph right here. If I have 1 edge, then I can draw this graph. And in fact, this is the only graph with 4 vertices and 1 edge. If you try and draw another one like this one, they're actually isomorphic. And you can give an isomorphism really quickly. For example, if I label this A, B, C, D, then on the right I can label A, D, B, C. That labeling demonstrates that they are isomorphic. So that's not actually a new graph, so I can just erase it. And in fact, there's only one graph with up to isomorphism. There's only one simple graph and 4 vertices with 1 edge. So let's think about 2 edges. So with 2 edges, I could do something like this, or I could do something like this. Okay, and these are not isomorphic. One way you can see they're not isomorphic is this is a vertex of degree 2, whereas on the left all the vertices have degree 1. So they're not isomorphic. And in fact, this is all of the graphs with 2 edges. There's no more graph with 2 edges. Okay. You should check all of my claims independently, right? When I say that there are only 2 graphs on 4 vertices with 2 edges, you should make sure that you believe that that's true. So let's think about 3 edges. So I could draw something like this. That's got 3 edges. I could draw something like this. And I could draw something like this. Okay, and I think it's clear that each of these is not isomorphic to the other ones. I mean, a quick argument could be like this graph here has 2 vertices of degree 2. This one has 3 vertices of degree 2, and this one has no vertices of degree 2. So they're not isomorphic. Okay. And it's up to you to independently check that if I draw something like this, this isn't actually a new graph. In fact, this graph is the same, it's isomorphic to that graph. Okay? It's not actually a new graph. So there are only 3 graphs with 3 edges on 4 vertices. So let's move on to 4 edges. Okay, well, I could draw a graph that looks a bit like this. I could draw a graph that looks a bit like this. And I think that's it. It starts getting a bit more confusing now, right? But I think this is the complete these are all the simple graphs on 4 vertices with 4 edges. And again, why are these not the same? Well, you could argue something like this is a degree 1 vertex, but on this graph there's no degree 1 vertices. Okay? And now it's up to you to independently check that something like this is not actually a new graph. Okay? This graph here is the same as that graph there. It's isomorphic to that graph right there. So it's not new, so it doesn't deserve a place on my list. Okay? 5 edges. So if I have 5 edges, I could be something like this. And I think that's it. I think that's the only graph with 5 edges. So again, up to you to check that. I'll draw a better picture. This and this are actually isomorphic. These two graphs are actually isomorphic. Okay? I could give you a quick labeling to demonstrate this. So I could label this A, B, C, D. So A has degree 2, D has degree 2, and then B and C. Like that. So that's a labeling which demonstrates they're isomorphic. But all that matters is it's not a new graph, so I should erase it. Okay, so how many more edges can we fit? Well, I could consider graphs with 6 edges. And remember, it has to be a simple graph, so no loop edges and no multi-edges or anything like that. And this is the only option when you're dealing with 6 edges. Okay, and there are no graphs on 4. There are no simple graphs on 4 vertices with 7 edges. There's just not enough room. Okay, you can't fit 7 edges without having at least one loop edge or at least one multi-edge. So that's it. Okay, so this here, if I can fit it on one screen, is a complete list of all the simple graphs on 4 vertices up to isomorphism. Okay, and you can continue doing this sort of game. You can continue doing this sort of game where the next thing to do would be to consider how many simple graphs there are on 5 vertices, and so on and so on. And obviously mathematicians have done this. So example/theorem. And mathematicians have counted these things and they've tried to record. So I'll just tell you the answer. Number of vertices and number of simple graphs up to isomorphism. If I draw a table, 2, 3, 4, 5, 6, 7. Well, if you just have 2 vertices, we didn't talk about this, but it's really trivial. If you just have 2 vertices, there's exactly 2 graphs. There's the graph with no edge and the graph with 1 edge. Okay. So there are 2. When you have 3 vertices, we worked out that there are 4. When you have 4 vertices, we worked out just up here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is the 0 edge graph. Okay? So you have 11. When you have 5 vertices, you have 34. When you have 6, mathematicians have worked out that you have 156. And when you have 7, you have 1044. Okay, obviously, I don't expect you to memorize these numbers. I just think it's interesting to know that people have worked out and classified how many simple graphs there are on 7 vertices. And there's a lot. There's 1044. And the list continues. It might be interesting to note that there's not actually an easy formula that gives you the answer. So there's not like some sort of function where you plug in the number of vertices and it gives you the number of simple graphs. There's no nice answer to this question. It's something which mathematicians have been working on for a long time, but there's still no nice answer. So this is simple graphs with few vertices. That's the end of this video.